So, I have the input common mode voltage, which is the bias, and I have I naught, and here I have plus half the difference and minus half the difference. Okay. So, now right now we were just wasting the currents. So, we had an incremental current GMVD by 2 there, and this way also it was the same. Now, let us say I connect a load like this. What is the incremental voltage over there? First of all, what is the operating point voltage over here? VDD minus I naught RL by 2. Let us assume that all transistors are still in saturation. Each transistor is drawing I naught by 2, that passes through RL. So, there is a drop of I naught RL by 2 in the resistor. So, we have VDD minus I naught RL by 2. Okay. And what is the incremental voltage? If I apply plus VD by 2 and minus VD by 2, what is the incremental voltage over there? Minus? I mean, it is just this incremental current times the resistance GMRL by 2 times VD. Okay. So, if you have a difference input VD, this gives you a gain of GMRL by 2 to one side. Okay. Then if I connect RL here, this will also have the same operating point VDD minus I naught RL by 2, and there will be an increment. How much is that? Plus GMRL by 2 times VD. It will be exactly negative of that, right? This you know, if you have a symmetrical circuit with antisymmetric excitation, in each half circuit there will be some voltage, and the voltage in this half circuit will be simply the negative of voltage in the other half circuit. Okay. So, if you are I mean, you may want to go and refresh the concepts of half circuits and so on, which we discussed earlier. And I can also look at the difference between these two. Okay. The output itself could be thought of as the difference between those two, and what is that? GMRL times VD. Okay. So, basically it is like a common source amplifier, you will have a gain of GMRL. Okay. This is fine. So, to one side I have minus GMRL by 2 times VD, to the other side we have plus GMRL by 2 times VD. You can use either one, or you could even use the difference between the two to drive the following stage. Okay. So, now this is a differential pair amplifier, this is a differential pair with a resistive load, and it will have all the limitations that we had as a common source amplifier with a resistive load, right. The gain is proportional to RL. So, you can try to increase the gain, but what happens is you have to go on increasing the supply voltage, and you will never be able to approach the inherent gain of the transistor. Okay. So, you will not be able to get a gain of 100 without having a supply voltage of hundreds of volts. Is it okay? But this amplifier is also used. If you have a situation where a small gain is enough, then you can use this, right, just like you would use a common source amplifier. The interesting thing is, now this will respond only to the difference of two inputs. So, that is useful in many cases. Okay. But we started off saying that we want to make an op amp. That means that we have to shoot for much higher gains than this. Here we may get 10 at most or something. So, what is the technique to use get a much higher gain? What did we do? Yeah, but I mean cascading is fine, but I mean if you have a gain of 5 from this, to get to 1000 already you have to cascade so many stages, and then you have to deal with stabilization of that complicated feedback, right. What is the first thing? I mean, you try to get as much gain as possible from each stage, and then you cascade as many as you require. Okay. Active load. Okay. So, I have to use this with an active load for high gain, right. How do I do that? Let me just take one output for now. This is VDD, this is VICM plus VD by 2, VICM minus VD by 2. Okay. The output would be the operating point voltage. After a while, I will stop writing this, VDD minus I naught RL by 2 plus GMRL by 2 times VD. Okay. Yes. No, I mean I have not done anything yet. I just wrote the symbol. So, we have not yet figured out how to get this VICM plus VD by 2 and so on. Okay. I will assume, I mean just imagine that however the voltage got here, VICM denotes the bias voltage and VD denotes the incremental voltage. How exactly we supply the voltage, I have not yet used. I mean I could AC couple for instance, but of course I have also been saying that you can't use AC coupling within an op amp. So, when we make the complete op amp, it will become clearer. Okay. No, right now, I mean, you can include it if you want, it won't change anything of the analysis that we are doing right now, but you can think of VICM as only the bias voltage that you set and that lowercase VCM as any common increment to the two sides and lowercase VD as the differential increment between the two sides. Okay. But yeah, I mean that lowercase VCM could be thought of as simply modifying the value of VICM, right, it is the same thing. This business of biasing and increment, right. So, when you add the input of an amplifier, let us say even the common source amplifier, at the gate you have to supply some bias plus some signal. Okay. So far we have been assuming, like he said, that our signal source is something that is grounded and then to that we have to add some DC bias and so on. But it does not matter how we get it, finally we have to get the DC bias plus the signal, right. So, that we will see how it happens later. So, now yeah, this has this problem that gain is limited. Okay. So, I have to replace the resistive load by an active load. How do I do that? What should I use? What should I use instead of RL as an active load so that we get a very high gain? PMOS. Okay. So, essentially what I want is really a current source of value I naught by 2, right. So, that way I mean the incremental resistance of that would be infinite and assuming that it is biased correctly, it will give a very large, it will give an infinite gain. Okay. So, for now assume that it is in saturation, we will later see how to arrange for that. Okay. We will have to evaluate the limits, right. I mean if we try to do that now, it will not make any sense at all. So, let us assume that everything is in saturation and move on. Okay. So, now this should behave, remember the quiescent current here is I naught by 2, the quiescent current here is I naught by 2. Okay. So, now this transistor must be biased such that it will have a current I naught by 2, right. Otherwise, what will happen? Again you have, yeah, exactly. So, let us, I think this again we have discussed, right. In fact, it was in some tutorial. So, this is an easier thing to visualize. So, let us say I have a current mirror and this is I naught by 2. So, if this is in saturation, it will carry a current of I naught by 2. But let us say I do this, what happens in this case? What will happen? What will happen? M2 will go into triode. Okay. So, first thing to remember is that the in saturation this will supply a current of I naught by 2. It can always supply a lesser current, it can never be more. right. So, a transistor, let us say its gate source is biased at some value, it has a certain saturation current for that gate source voltage. So, a transistor can have less current, obviously the transistor's ID VDS characteristics look like this, right. This is the saturation current, but it can have less if it operates here. So, it has to go into triode region. So, in this case the current will actually be I naught by 4 and it will be in triode region. Okay. What happens if it is that? What happens in this case? So, if this is truly an ideal current source, this voltage will go up to infinity, okay. But of course, this is also a real current source. So, maybe it comes from a PMOS current mirror like this, okay. So, if this was in saturation, it would carry 3 I naught by 4. So, what happens in this case? What will be the current flowing in this branch eventually? I naught by 2, okay. The smaller of the one will prevail, right. So, this can supply I naught by 2, but when it is in triode region. So, it will go up into triode region. So, the point is whatever active load you have, if you have to have any chance at all of both being in saturation, okay, this has to be supplying I naught by 2, at least its saturation current must be I naught by 2, okay. That is the only way it will work. So, please think about an arrangement which will make that happen. We will continue the discussion from there.